Hello, in this video we will present you our Java project. Let's start. We will start our presentation with a description of AStar Algorithm. The AStar Algorithm is a graph search algorithm that operates according to specific heuristic function on a graph, such as air distance heuristic or Manhattan distance heuristic. This algorithm finds the cheapest path from the start node to the end node of the graph according to cost function. The cost function includes information from heuristic and information that's known from the graph.
Let's move to the Eclipse. Now we will present to you how our project works. First, let's start our server by pressing the button Start Server. Now the server is running and waiting for connection from clients. Let's connect two clients and create a maze in each client. Now let's present the mazes in the clients and run the solution for each of them. Look how nice the algorithm works. We can notice that the server treats both clients in a parallel way, and that's because the thread pool. Every client is handled in a different thread. Although the clients are in the same computer, each client is connected from a different port. The server saves the mazes of a client when it disconnects from it in a zip file. We can see that when we close the server and all the clients, there is no thread in the background, errors or open communication channels. They are all terminated.
Now we will present the architecture of the client. The client side uses the MVP architecture, model, view, and the presenter. The purpose of this architecture is to separate the view side and the model side. The model has the responsibility for all the calculations and the database's accesses behind the scenes. The view has the responsibility for presenting the data to the client. The model and the view are not supposed to know each other, but there is a connector between them, the presenter. The presenter links between the model and the view by using the observer pattern. The main purpose beyond this architecture is to allow many groups to work on the same project in a parallel way without being dependent on each other. The different teams are not supposed to know each other's code. Furthermore, the layers partitioning creates simplicity with checking errors in the code, and it's easier to maintain it.
Let's move back to the Eclipse. The user can only see the view side. The client requests some actions and notifies the presenter. The presenter checks what is the request and transfers it to the model side. Which in his turn passes it to the server. After calculating, the server transfers the data to the model, which notifies the presenter. The presenter transfers the information to the view, and the view displays the user request by using widgets that belongs to SWT jar.
Our server uses the MVP architecture, the same architecture we use in the client. In addition, the server works on a communication protocol, TCP. This protocol ensures reliable data transfer between two stations by creating a network between them. In this protocol, the server creates a socket, binds, and waits to connection. When a client connects to the server creates another socket and still binds to another. In the new socket, the server communicates with the client and handles his requests. Now the client can transfer requests to the server. When the client wants to close the connection, he closes the socket, and when the server will accept that, the socket will be closed.
Thank you for listening. Goodbye.